All right, 13.5, law of sines. What we're talking about and why we dealt with law of cosines first is that law of sines has some funky things that show up when we use it. And so it makes it a little more difficult. The law of sines, when you have the ratio of the angle to the side, the sine of the angle to the side, you can set it equal to the ratio of the others. You only ever need two of these to make a proportion that you can solve. So sometimes it may be the first two, sometimes it may be the last two, sometimes it may be the first and the last, but ultimately it's just the sine of some angle over the side across from it. So draw a triangle ABC. Angle A is 40 degrees. Side A is 15. Angle B is what we're trying to find, and side B is 20 long. So we've got our triangle. We have an angle and a side, and so we have side angle, and I'm not writing this down just because we're putting it down on video. So remember, this is the one that gave us trouble in geometry, where you weren't allowed to say that we had two congruent triangles if we had side angle. Same problem is going to show up here. Is you may have one triangle, but you may have two possible triangles depending on how this 15 is allowed to flip out. Is it inside? Is it outside? And that's all dependent on what goes on with your angle. So, sine of 40 over 15. It's the ratio of the A over the A. And the sine of some angle B equals, over 20. Now, the thing to keep in mind is if you're finding the angle, I put the angle on top, but you can always flip this ratio over and it'll be easier to find the side if you start with the reciprocal property. So, if you multiply both of these by 20, the 20s cross out and you're left with 20 times the sine of 40 over 15 equals B. Equals the sine of B. So again, we're dealing with degrees, and so we want to be in degree mode. 20 times the sine of 40 divided by 15. And so we have this 0.857 equals the sine of B. Remember how we find the angle is by doing inverse sine. Inverse sine of 0.857, and that'll give us angle B. Inverse sine, and I'm just going to do of the answer, and get 58.98. So if I want to round to the nearest tenth, it'll be 59.0 degrees. Now, the sine isn't just positive in that first quadrant. You have to think sine is positive in this quadrant with my 59 degree angle, but also in this quadrant. And I could reflect it over where this is 59 degrees and this is also 59 degrees. Because the y value is what we're looking for. The y value is positive in both cases. And so another angle that will give me 0.857, but my calculator won't necessarily give me because it only ever gives that one answer, is 180 minus 59. 180 minus the 59, and that'll be the 121. And so that's another possible angle for B. Because if you do the sine of 121, you get that 0.857 again, just like we got before. And so the key thing here is anytime you have side angle, you have to look for that second possible triangle. So angle B could be 59 degrees, but it could also be 121 degrees. Now, obviously that changes up with, if that's your angle B, then angle C is going to be different because 180 minus 40 minus your 59 would leave 81 degrees. But if you did 180 minus 40 minus 121, that only leaves 19 degrees for angle C. And so in this third angle, that's where sometimes it's going to be possible, sometimes it's not. If you're already past 180 with our 40 degrees and our 121, our second angle, it's not going to be possible to have two. But in this case it is, because there's room for that second one. There's two possible triangles, and we could find the leftover sides if we did law of sines again. So, new triangle. What if the side is 8? This is still A, B, C. Angle A is still 40. Side A is still 15. And so I'm still going to set up sine of 40 over 15. Sine of the angle over the side equals sine of the angle over the side. And so I'm going to solve it the same way. Multiply by 8. Multiply by 8. It's the same situation, but I want to show you a different result that can happen. So 8 times the sine of 40 divided by 15 is the sine of B. So I'm going to take it up here. 8 times the sine of 40 divided by 15. 0.343. And that equals the sine of B. Inverse sine of 0.343 is my angle. And so inverse sine of the angle, remember we're hitting inverse sine by hitting second and then the sine button. And that gives me 20.0 degrees. So if I were to find my second angle, 20 degrees is right here. I have to do 180 minus 20 to find the 160 degree angle that's possible for B. Now, with angle A already being 40, these already add up to be more than 180, and so that's why the second angle B is not possible, and that's why you have just the one triangle possible in this case. So find angle B. Angle B is 20 degrees. So, next problem. This time we're trying to solve for triangle ABC, and what that means is we're going to find every single missing part. Most of the triangles I draw just look like equilaterals. I don't try to draw them to scale because it just takes longer. B is 34. Notice in this case we have side-side angle again. Sine of your angle 62 over 32 equals sine of some angle B over 34. I'm going to solve this one the same exact way. 34 times the sine of 62 over 32. So we get 0.938. Inverse sine of that is 69.7 degrees. Inverse sine of 0.938 equals 69.7 degrees. So that's angle B. Angle B is 69.7. And so what we can do is, again, 180 minus that. (180 minus 69.7) is 110. And so that's another possible triangle that we have. because 62 plus 110 is still under 180. So A, B, C. So two possible triangles we have going. Triangle 1, triangle 2. Triangle 1, we got angle B was 69.7. Triangle 2, angle B was 110.3 degrees. All right. So that leaves angle C. You're going to subtract from 180 to find those two. So 180 minus our 62 minus our 69.7 leaves 48.3. If we do 180 minus 62 minus our 110.3, that leaves 7.7 degrees. And finally, to solve for side C, we're going to have to use the leftover ratio. You can't use Pythagorean theorem because we're dealing with a non-right triangle. So we deal with C over sine of the angle C. Notice how I'm flipping it over because I want the angle on top, or the side measure on top, and then I'm going to do 32 over the sine of 62. I'm doing this so I can easily multiply by the sine of 48, so that multiply both sides by the sine of 48 and it goes over to the other side. 32 times the sine of 48.3 over the sine of 62. So 32 times the sine, 48.3, divided by the sine, 62. And so C, side C, is 27.1. And if we do the opposite one, sine C over the sine of 48, but now we're going to deal with angle C being something else, and so it'll be 7.7 degrees. But it's equal to the same ratio, 32 over sine of 62. So I multiply the sine of 7.7 to the other side. Multiply both sides by 7.7, sine of 7.7. And so I'm going to hit second enter and just change my angle here, 7.7. And so then side C is the shortest side. And so it all depends on your side-side angle situation. Now, not all of them are that tricky, but that was the trickiest you'll find, is because you have two triangles possible.